This video is on Le Chatelier's principle. Now, Le Chatelier stated that if a system is already at equilibrium and it is subjected to a stress, it will cause a shift, and the shift will relieve the stress. Now, that probably means nothing. So let's first talk about a shift. Now, remember, when we're at equilibrium, the concentrations are constant, the rates are now equal, okay? That's this, and we're at the lowest possible energy state, right? So let's imagine we stress the system. Well, what are the three stresses? Well, there's three of them. We can change the pressure of the system, but that will only affect things that are, you guessed it, gases. Okay? We can change the temperature of the system, and the other thing we can do is change the concentration of something, and that means it could be a reactant or a product, and we could either do that by adding something, we could add something, or we could remove something. Adding is much easier. Removing usually involves things like precipitation, because you can't just stick your fingers in and take an ion out of a solution, but you can precipitate it out, and then it's no longer dissolved, and that would be a way of lowering the concentration. So, every question on the Regents basically asks the same thing. They're going to ask you either to figure out what the stress is, okay, that caused the shift. Now, the shift is basically this. If you stress a system and it causes more reactants to get made, we call that a shift to the right. And when the shift to the right happens, the amount of the products is going to go up and the amount of reactants is going to go down. Okay, if you shift to the left, it will be the opposite thing. Right, so if you shift it to the left, all of a sudden some of the products get turned into reactants, and therefore the amount of reactants goes up, and the amount of products will go down. Okay? So they'll either ask you what the stress is, they'll ask you what the stress causes, will cause it to shift to the left or the right, and they'll also then ask you about the changes in the concentrations of things. Because if you shift to the right, you make more product, the concentration of the products will go up, and the amount of the reactants is going to go down. And they can ask them in any order, but really it's stress, shift, change in concentration. But they could give you the change in concentration and ask you which stress would cause it to shift to the right, so the concentration of a product would go up. So they could be like, this stress made it, which stress made the amount of product go up? And you know that means it went to the right, and so you have to figure that out. Okay, let's do some examples here. Here we go. So let's start with concentration as our first possible stress. And let's imagine we have a system at equilibrium. So at equilibrium, like in the POGL that we did, we have a really simple equation where we have A and B, and when we get to equilibrium, there's 10 molecules of B for every 1 molecule of A. So the first variable is concentration. Now the general rule is when you increase the concentration, okay, if you just memorize this, it will get you through most questions, it will always shift away. If you lower the concentration of thing, it will shift towards it. What that means is if you add some A, right, so if you add more A, it will shift away from it. If you add more B, it will shift away from it to the left. Okay, if you remove B, it will shift towards it. So if you remove some B, it will shift to the right towards B. And if you remove A, it will shift towards A. Now, the shift basically means that if you shift to the right, you're going to end up with more of it. So if you remove it, it's almost like it gets replaced. So you remove B, it shifts to the right, you get more B, and less A, and vice versa. Now, the way to kind of think of this, if you really want to understand it, which you're never going to be asking the Regents, but it might help, is to think about this in terms of those equilibrium constants, right? So if you imagine this really simple reaction, and these are the molarities, which they're very big, but it's to illustrate a point. You know, you can think of this like K equals, 100 over, 10. These are the concentrations, let's say, which means K in this case is equal to 10, right? Now imagine I'm going to erase some things there. So imagine you were to change this, and all of a sudden, like, this stays at 10, right? But you raise the amount of B to let's say, 210 mole, which is crazy, but just to illustrate the point, well, if you put 210 over 10, you don't have 10 anymore, right? But think about this. If it's going to shift away from it, that means it's going to go this way. Well, what's going to happen if it shifts to the left away from B because you added B? Well, that means the amount A is going to increase, the amount of B is going to go down. And really this is because all of a sudden you have more molecules of B, so for a little while the reverse rate just speeds up. Because you have more B molecules, there's more collisions. That's the connection with what we've been doing the whole time. But in the end, you're going to have it switch to this point where you're going to get some sort of a similar ratio. So you may get a situation where you end up getting like, 180 over like, something like 18, something where, now this is not exact, obviously, but you see what happens, the amount of B goes down, the amount of A goes up, and we end up getting 10 again. So whenever you add something, it shifts away from it to restore the sort of equilibrium balance. Okay? Whenever you remove something, it shifts towards it. So if I were to all of a sudden like remove like a whole bunch of B, make it like much smaller, like maybe make it like 50, then all of a sudden, right, I'm sorry, it's supposed to be 50. And all of a sudden it's going to shift towards it, and the amount of A is going to go down, and the amount of B is going to go up. So A will go down to like 5-ish, and B will probably go up to like 50-something, it's maybe 55-ish or something like that, and that it'll get close to the same exact ratio. Now the reality is you end up with fractions and decimals, so I'm not going to try to do the math here, but you end up with the same ratio. Now you can apply that to a more realistic situation, like the one below. If you add N2, okay, it will shift to the right. What does that mean? The amount of NH3 will go up, and the amount of H2 will go down, because that means you're making more of this, you're going to use up some of this to make this. So whenever you shift away from something, the stuff that you shift away from goes back down again, and the stuff on the right goes up. Now, make sure, because they never ask you about the thing that you're adding, because it's confusing, because it goes up and then back down. If I were to add, NH3, right, it would shift to the left, which would mean the amount of N2 and the amount of H2 would go what? That's right, it would go up because we're shifting to the left. Now the NH3 is going to go up, but then it's going to go back down. And at some point, we're kind of restore that ratio so we end up with the same equilibrium constant. Okay? Now if you remove something, it shifts towards it. So if I were to remove, let's say, some NH3, so if I were to remove NH3, so if I remove NH3, let me try to remove NH3. Sorry, I was trying to change my pen from erase mode. It's going to shift towards it instead, which will raise the concentration back up, but the concentration of both these guys is going to go down, because as you make more product, you consume reactant. I always kind of think of it as like making pizza or something like that, because I use the same food analogy. But, if all of a sudden, you're at Savino's and all the pizzas have been removed, okay, then that's like, all of a sudden we're like, oh, we got to make more pizza. So what's going to happen? Well, they're going to break out the dough and the sauce and the cheese and whatever else they're going to need. And what's going to happen? Well, the amount of pizzas are going to go up, that's our product, and the amount of all the ingredients is going to go down, right? So when you remove something, it shifts towards it, okay? And when you add something, it shifts away from it. Now, for another example, which I think it's worth two of them, physical equilibriums that involve solutions can be complicated because they can add things by not adding what's in the equation. They really are, though, and they can be a little tricky. So a lot of times they'll add what's called a common ion. So, for example, this is calcium chloride, and you can see there's calcium ions and chlorides. And remember, this is a saturated solution, right? So no more solute can dissolve in it. And that will be important a little bit later on. But you can add a different solute. So like the water in the ocean isn't just NaCl water. There's lots of different ions in there. Okay, you can have more than one thing dissolved in water. Okay, so you can add some table salt, NaCl. Now what's important about the table salt is you're adding sodium ions, which are not in the equation at all, so they have no effect. But you're also adding chloride ions. And chloride ions are in the equation. They're right here. And so you're essentially adding what's called a common ion. Calcium chloride when it dissolves, produces the same ion as sodium chloride produces when it dissolves. They have an ion in common. And because you're adding the chloride ions, it's going to shift away because you're adding it. And when you add it, when it shifts away, it goes to the left. Now what that means is the chlorides are going to go up, but then down. And again, they're never going to ask about that because it's confusing. But they'll ask you about the calcium, and they'll ask you about the calcium chloride. Okay, since it's shifting to the left, what's going to happen to the amount of calcium ions? They're going to go, that's right, they're going to go down. And what's going to happen to the amount of solid calcium chloride? It's actually going to go up. So you'll actually basically, and when you add a common ion in general, what they say, you decrease the solubility of the salt, because when you shift to the left, some of the calcium chloride that was actually dissolved will precipitate out. It'll actually become less soluble in the presence of a common ion. Okay, and you could do the same thing with the other ions. So instead, I could add, calcium iodide instead, which is my second example, right? Except this time the common ion is a cation instead of an anion. So I'm adding calcium ions and iodides. The iodides don't have an effect; they're not in the equation, but the calcium ions do, and they'll have the exact same effect. When you add calcium ions, it will shift to the left. The amount of chlorides will decrease. Okay, and the amount of solid calcium chloride will actually increase. And again, that means it becomes less soluble. Okay, and that's what a common ion does. It actually decreases the solubility of a compound. So there's something else besides temperature that can change the solubility of a compound. Now, adding things seems almost common sense, comparatively speaking, to precipitation, but we've seen these types of chemical reactions. Okay, one of the things we used several times in the lab was we used silver nitrate. Okay, now I don't really care about the nitrate at all here. What I do care about is the silver ions. Silver chloride is insoluble, so if you throw some silver nitrate into the water, okay, you're essentially going to see a double replacement reaction. What's going to end up happening is you're going to form solid AgCl, solid, and that's essentially a way of saying I'm going to erase all this stuff here. I am removing this. I am actually going to decrease the amount of this. So I'm going to remove Cl minuses. When they turn into solid, it's like you're taking them out of the water. They're no longer dissolved. They become less concentrated, more dilute. And if you lower the concentrations, that's like removing them, and that's going to shift it towards instead of away. So if you can precipitate out something, it has the opposite. It actually makes it more soluble. And what happens is the amount of solid calcium chloride is actually going to decrease because you're actually going to increase the amount of calcium ions in the water. And they say the solubility of the calcium chloride will go up. Now, the other thing I should mention here is if you add more CaCl2. Now, assuming that none of these other things have happened here and we have the original saturated solution. So forget all this other stuff, right? If we just have our little saturated solution that we started with of calcium chloride, right? If you add, now it's already saturated, isn't it? So if you add more calcium chloride, is it going to dissolve? No, of course not. It's already saturated. If it doesn't dissolve, it doesn't change the concentration of anything. And so it actually has no effect. You can't cause a shift by adding something that's already saturated. It will have no effect. Now,